Today we're going to take a look at naming polynomial functions and writing polynomial equations from their graphs. The first thing we're going to do is look at three very common parent functions so we can figure out what's going on with our polynomial graphs. Here we have y equals x. If we graph that, it makes a line. Now keep in mind the exponent that goes with this is 1. So if we have a line, we know the multiplicity is going to be 1. We learned about that last class, what multiplicity is. Here we have y equals x squared. So if we graph that, we end up getting a parabola. And the exponent that goes with that is 2. So if you see a parabola, you'll end up knowing that there's a multiplicity of 2. Here, when we have an exponent of 3, we know that it's a cubic function like this. It kind of flattens out there in the middle. I guess when you zoom in, it looks a little rough. It's closer to this. So when you see a cubic, you know that there's a multiplicity of 3. So we're going to keep these in the back of our head as we look at this polynomial. So we're going to write an equation for this graph, and you might be saying, whoa, there's a lot going on. But we are going to zoom in a step at a time and look at each of our x interactions. So here, if we zoom in and we just look at this box right here and only focus on what's going on inside there, what do you see? You see a line inside that box. So we can think of it as, oops, that's the eraser. We can think of this as a line going through at that point. It doesn't matter what's going on everywhere else. There's just a line going through at that point. Where is that 0? Well, if we count the blocks, it's at 1, 2, 3, 4, 5, 6, 7. It's at -7. So we know we have a line at -7. So what we're going to do is we're going to write the zeros and their multiplicity. So we know we have a 0 at x equals -7, and we know the multiplicity is 1 because we have a line right here at -7. Our next occurs at -3, so x equals -3, and we know we have a multiplicity again of 1 because it makes a line going through it. Here's where things get a little bit different, is here. If we zoom in and just look inside this box, what do you see? You see a parabola. Even though it's upside down, it's still a parabola. So that changes our multiplicity to 2 because we learned up top when we see a parabola, the multiplicity is 2. So here we're going to come down and we're going to say at x equals +3, we have a multiplicity of 2. And then finally, at x equals 6, we're going to have a multiplicity of 1 again because that's just a line. So what are we going to do with those factors? Well, we can use these factors to write an equation. So we're going to say y equals, and we're going to say x plus 7 because that's the factor that goes with -7. And since there's a multiplicity of 1, you can put a 1 right there, but you typically won't see it, so I'm not going to either. Then the next factor is x plus 3. The next factor is x minus 3, but this time because the multiplicity is 2, we're going to raise it to the second power. And then finally, x minus 6. So notice I left a little gap right here. And the reason why is if you were to put this into a graphing calculator like Desmos, you would find that it makes a line right here. It makes a line right here. It goes way down super low. It makes a parabola here, and it makes a line right here. So everything about it is almost perfect here, 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 and here. The problem occurs right here, our y-intercept. If you leave this as it is, it won't go through the y-intercept. So the last thing we're going to do is we're going to put a number out in front, and I'm going to call this number a. You could technically call it anything you want. A is just the first letter in the alphabet. We are going to solve for a, so that way not only will our function go through these 4 points that we've taken care of, but that a value is also going to ensure that it goes through our y-intercept. So our y-intercept right here is the point 0, -4. So when x equals 0, y equals -4. We can use that to rewrite our equation Everywhere you see a y, you're going to put a -4, and everywhere you see an x, you're going to put a 0. So -4 equals, we're going to leave that a alone, and then we're going to put 0 in. So 0 plus 7 is 7, 0 plus 3 is 3, 0 minus 3 is -3 squared, and 0 minus 6 is -6. Now what you can do is you can put this in your calculator to figure out what that all is going to equal. So we'll end up with -4 equals a times, all of this together gives us a pretty big number, and that's okay. It's 1134. Sorry, -1134. So to get a alone, notice that you're multiplying by -1134, so we're going to divide by -1134. So a is going to equal -4 over -1134. And if you reduce that fraction, either in your graphing calculator, you can hit math, enter, enter, or in Desmos, you can hit the fraction button, you will get 2 over 567. So now our final step, now that we know our a value, is we can take that a value and put it back into our original equation. So our final equation is going to be y equals our a value, which we found to be 2 over 567, and then your factors. So now if you take this answer and put it into Desmos, you'll find that not only does it cross each of the x-intercepts correctly, but it's also going to touch the y-axis where you need it to as well. All right, so we're going to do this process again, but this time we're going to jump right into writing our factors. So we're going to say y equals, and then we'll put an a placeholder that we'll use later, and then we'll write our factors. So here, if you zoom in and just look inside this box, it's a line, and that line occurs at -6. Oh, sorry. Okay, so that line occurs at -6, so we are going to make our factor at +6. So our factor will be x plus 6. Then here we've got a parabola, and that occurs at -1, so our factor will be x plus 1. And since it's a parabola, we need to make our multiplicity 2, so we're going to have an exponent of 2. And then finally right here, we've got another parabola, and that happens at +5, so x minus 5 squared. So that's the first part done. So the only thing that's missing is we need to make sure we go through our y-intercept, and our y-intercept is the point 0, -1. So wherever x equals 0, we're going to let y equal -1. And we're going to substitute that into our equation so we can solve for a. So -1 equals a, and then we're going to put 0 in for all of our x's. So 0 plus 6 is 6. 0 plus 1 is 1 squared, and then 0 minus 5 is -5 squared. We'll put this in our calculator. We'll clean it up a bit. After you put that in your calculator, you will get -1 equals a times 150. So finally, to get a alone, it's being multiplied by 150, so we'll undo it by dividing by 150. So -1 over 150. And now we can write our final equation, because now that we know our a value, we can substitute it back into the original. So your final equation is going to be y equals -1 over 150, and then copy down all your factors: x plus 6, x plus 1 squared, x minus 5 squared. Okay, there's 2 on the next page for you to try, so pause the video and try them now, and then you can come back here and see them worked out. All right, so moving on to the next 2 examples, here's example 3. We're going to start by writing y equals, and then our placeholder a. Sorry, y'all, I'm having a rough time. Here we go. All right, that jumped me back up. So y equals, and then our placeholder a. And then we're going to write our factors. So here we have a factor at -3. So the factor is going to be x plus 3. And since that's cubic, that's to the 3rd power. Then we're going to have a line at 3. So x minus 3. and a line at 6, so x minus 6. So now we need to find our y-intercept, which is the point 0, 4. So everywhere we see x, we're going to put 0, and everywhere we see y, we're going to put a 4. So 4 equals a times 3 cubed times negative 3 times negative 6. So we get that 4 is equal to a times all of that put in our calculator. And when we put that in our calculator, we get 486. So divide both sides by 46, and a equals 4 over 486, which reduces to 2 over 243. So now you can write your entire equation. We're going to take that a value, put it back in up here. So y equals 2 over 243 times x plus 3 cubed times x minus 3 times x minus 6. All right, sorry, that went off the page. There it is. All right, here's the last one. Okay, so we're going to start the same way. Y equals, and then an a value, and then we're going to write our factors. So here, be careful. I know it looks like a parabola, but you only care about the places where it touches the x-axis. So here, we've got a line. We've got a parabola here. Don't worry about that parabola there. It doesn't mean anything. We don't care about it. Then here we have a line. And then here we have a little cubic. You can tell it's a cubic because it levels out there for a second at the x-axis. All right, so here's our equation. Forgive me, y'all. I'm trying to get it to scoot over. Okay, there. So we're going to write our factors. So we're going to have x plus 7, x plus 5 squared, x plus 1, x minus 2 cubed. So our y-intercept is at the point 0, 2. So everywhere x equals 0, y is going to equal 2. So we can rewrite our equation. 2 equals our a value. And then we're going to substitute 0 in for x. So 7, 5 squared, 1, and negative 2 cubed. We can put this in our calculator, figure out what that's going to be, and we're going to get that 2 is equal to whatever our a value is times negative 1400. So we'll divide both sides by negative 1400. A equals 2 over negative 1400, which reduces to negative 1 over 700. So now, as usual, we can take this a, put it into our original equation, and we're going to have y equals negative 1 over 700, x plus 7, x plus 5 squared, I've run out of room, I'm going to write it below, times x plus 1 times x minus 2 cubed. Pretend that's all on one line. It is on your key on Canvas. So the last thing we're going to do is talk about naming polynomials. This is just vocabulary, so it's going to go by nice and fast. So there's two ways to name a polynomial, and that is by its degree. Degree is just a fancy name for the biggest exponent. And the number of terms, which is just how many pieces it has. They're always separated by a plus or a minus. So we're going to look at some examples. So if you need to pause as you go along so you have time to write it down, feel free. If something has an exponent of 0, so for example 6, there's no exponent, there's no variable to plug anything in, it's called a constant. It won't change. If something is to the first power like 2x, it's called linear. If something is to the second power, 3x squared plus 1, for example, it's called quadratic. If something is to the third power, like 4x cubed plus x, we call it cubic. If something's to the fourth power, we call it quartic. And if something is called to the fifth power, like 7x to the fifth minus 1, we call it quintic. And then after that, we just call it an nth degree. We don't literally use the letter n, we just say 8th degree, 12th degree, 7th degree. So for example, 2x to the 8th power minus 4x plus 1 is an 8th degree polynomial. Then we can also name them by the number of terms, and that's just how many pieces they have. So the first example is a monomial, and that is just one term. So 2x, that's just one thing. Then we have a binomial. The prefix bi means two, like a bicycle has two wheels. So 3x to the fifth plus 1 is a binomial because it has two pieces separated by either a plus or a minus sign. The third one is a trinomial. That's three pieces. So for example, x squared plus 3x minus 5 has three pieces separated by a plus here and by a minus here. And then finally, polynomial. After three pieces, we stop giving fancy names. Poly just means many, so many pieces. X to the seventh plus 4x squared minus 2x plus 1. So below, we're just going to name the following by their degree and their number of terms. We always put degree first because it's an adjective, and then the number of terms second because it's a noun. So if you want to pause it and try it and then come back here to check your work, now would be a great time to do that. Okay, so here the biggest degree is 3, so this is cubic, and it's two pieces, so it's a binomial. Here the degree is 2, so it's a quadratic, and it's three pieces, so it's a trinomial. Here the degree, well, there's not one at all. There's not even a single variable, so this is a constant, and since it's one piece, it's a monomial. Here the biggest exponent is 1, so it's linear, and there's two pieces, so it's a binomial. Here, the biggest exponent is 4, so it's a quartic, and it's one piece, so it's a monomial. And then finally, the biggest exponent here is 5, so we just say fifth degree. And then since it's more than three pieces, we call it a polynomial. So a many-nomial is a polynomial. And that's it. So now you can do your classwork, and don't forget to work on your test review.